Hi class, this is Mrs. Cornett. I'm going to show you some problems from your section 3.6, Solving Linear Inequalities. These first two problems, the instructions say determine whether each value of x is a solution of the inequality. So you're given an inequality, you have four values, a, b, c, and d, and I need you to check each value to see if once you substitute that value in for x, is the inequality still true? So let me show you what I'm talking about. For number 11, let's check b and d. If we check b, the value for x is -3. That would be 5 times -3 minus 12 greater than 0. 5 times -3 is -15. And then -15 minus 12 is -27. And is -27 larger than 0? No, it's not. And so you would put no next to answer choice B. Okay, let's do the same thing, except this time let x be 3/2. This is 5 times the fraction 3/2 minus 12 greater than 0. Anytime you're multiplying a whole number times a fraction, you can put a 1 in the denominator for the whole number and then multiply the two numerators together, which would be 5 times 3 is 15, and multiply the denominators together, which is 1 times 2, which is 2. And if we simplified 15/2 to a decimal, that would be 7.5 minus 12. Is that greater than 0? 7.5 minus 12 is -4.5, and that is not greater than 0. So answer choice D is also no. And just in case you want to go back and do these later, both A and C both work for this inequality number 11. Okay, turn your focus to number 12. The inequality is 2x plus 1 is less than 3. And we'll go ahead and check B and D again. For B, the x value is 4. This will be 2 times 4 plus 1, and we're going to see if that's less than 3. Well, 2 times 4 is 8. 8 plus 1 is 9. And is the statement 9 less than 3, is that true? Nope, it's not. And so you'll put a no for value B. Now if we check value D, x is 1/2. 2 times the fraction 1/2 plus 1 less than 3. Again, you can add the denominator of a 1 under the whole number 2. And so this would be 2 times 1 is 2. 1 times 2 in the denominator is also 2, which another way to write that fraction, 2 over 2, is just to write the whole number 1. So 1 plus 1, is that less than 3? And yes, it is. And so the answer choice to D is yes. And you can go back and work A and C. A will be yes, and C will be yes. Okay, for this next set of problems, I won't do all of these, but you're asked to solve the inequality and then graph the inequality on the number line. So let me just show you a few of them and show you how to graph them. If we start off really easy, like with number 22, t plus 1 less than 6, you're going to solve these exactly the way you would solve if that inequality sign was an equal sign. We're going to subtract 1 from both sides. That leaves us with t less than 5. That is part 1 of your answer. Part 2 of your answer will be what you graph on the number line. Now my number line doesn't have any numbers, but your number line on WebAssign will already have numbers filled out for you. So there's just a few numbers. And if you keep the format, your variable on the left side of the inequality symbol and your number on the right side, it's much easier to graph because you can actually use the inequality sign as a hint to which way to shade. I'm going to darken in this less than sign with a red marker. And can you imagine that that less than symbol is actually an arrowhead pointing towards the left? That's exactly how you're going to shade on the number line. You're going to draw a parenthesis at 5 because this is a less than. It does not have that equal to line across the bottom. And then you're going to color in or shade all of the numbers to the left of 5 because t can be any number smaller than 5. And all the numbers smaller than 5 are to the left side. Okay, take a look at 27. -10x less than 40. We're going to divide both sides by 10. That leaves us with x. Now, I have an entire video about this, so just look on Moodle for it. But when you divide or multiply by a negative number, the inequality sign flips. So it was less than, now it's greater than, and then the math will stay the same. 40 divided by negative 10 is negative 4. So this is part 1 of your answer. Part 2 of your answer is to graph on a number line. So here's negative 4, negative 2. Because this is a greater than symbol, we'll use parentheses again. Also imagine that this greater than symbol is an arrowhead and it's pointing towards the direction, towards the right direction, to the right side. So I want you to put a parenthesis on negative 4 opening towards the right. And we're going to shade in all the numbers that are greater than negative 4, and those are on the right side of the number line. Okay, take a look at number 30. 1/5 x greater than 3. We are going to divide by the fraction 1/5. And if you remember from our first unit, when you divide by a fraction, it's the same thing as if you were to multiply by the reciprocal. I hope you remember that. So if we put a 1 for the denominator of 3, and then we multiply by the reciprocal, which would be 5 over 1, we would have, that would equal 15. So part 1 of our answer is x greater than 15. Now we'll come down here to our number line, and I'm just going to put a few numbers for reference. The variables on the left side of the inequality, when it's in that format, you can use the inequality symbol to help point you towards which side you're going to shade. You're either going to shade to the right or to the left. That's the only two choices you have. So we're going to put a parenthesis at 15, and the statement says x is greater than 15. So we'll shade in all of the numbers that are bigger than 15. Okay, take a look at 32. 3x plus 2 less than or equal to 14. Let's begin solving this just like a regular equation. Subtract 2 from both sides. 3x, the 2 minus 2's cancel. The inequality comes down as less than or equal to. 14 minus 2 is 12. We're going to divide by a positive 3, and that leaves us with part of our answer, which is x less than or equal to 4. Now I'm going to come down here and do the second part on our number line. This is the first example that we've had an equal to next to the inequality, so this is less than or equal to. The trick with the arrowhead still works because the variable is on the left side and the numbers on the right. We can still highlight this in red and it still points towards the left, and that will be the way we're going to shade, except this time instead of an open parenthesis towards the left, we're going to have a bracket. The bracket represents that it also includes the value 4. We'll shade everything that is smaller than positive 4. Okay, let me just show you a few off of this one before the video gets too long. These slightly more complicated than the previous ones, but if you have a good understanding of how to solve equations with variables on both sides, then you can also solve inequalities with variables on both sides. Let's do number 40. It reads 25x plus 4 less than or equal to 10x plus 19. I want to make it where my variables are on the left side of the inequality symbol, so I will subtract 10x from both sides. 25 minus 10x is 15x, and then we have the plus 4 less than or equal to 19. Next, subtract 4 from both sides. That leaves 15x less than or equal to 15. Divide both sides by 15, and that leaves us with part 1 of our answer as x less than or equal to a positive 1. So down here on our number line, because this is a less than or equal to inequality, we're going to use a bracket. It's going to open towards the left because that's facing all the numbers that are smaller than positive 1, and then we're going to shade all those numbers smaller than positive 1. Take a look at number 41. It is 2 times the quantity x plus 7 greater than 12. Before you can solve this one, you need to first take care of the parentheses. And to do that, we're just going to multiply both the x and 7 by the positive 2. That's positive 2x plus 14 greater than 12. Now we can just solve this inequality by subtracting 14 from both sides. That's 2x greater than negative 2. Divide both sides by a positive 2. Part 1 of our answer is x is greater than negative 1. Because this is a greater symbol and it does not have the equal to, we are back to using just a parenthesis. And we're going to shade all of the numbers that are bigger or greater than negative 1. So the parenthesis is going to open facing towards the right side of the number line, and that's the direction that you will shade. I'm going to show you one more on this video, and that is number 45. Negative 2 times the quantity z plus 1 greater than or equal to 3 times the quantity z plus 1. Both sides of the inequality, you need to work the distributive property. This will be negative 2z minus 2 greater than or equal to 3z plus 3. From here, we'll just move some pieces around. Again, I like to move the variables to the left side, so I am going to subtract the 3z from both sides. That leaves me with a 5. That leaves negative 5z minus 2 greater than or equal to positive 3. Next, I'll add 2 to both sides, and that leaves me over here with negative 5z greater than or equal to 5. Now I'm going to divide both sides by a negative 5. So pay attention. Here's what's going to happen when I divide by a negative. I'm still going to have the positive z. 5 divided by negative 5 is still negative 1. The only thing that's going to change is the direction that the inequality symbol is facing. It is going to switch from a greater than equal to symbol to a less than equal to symbol. And like I mentioned earlier, I have a whole video explaining why it made the switch. That's part 1 of your answer. The last part is to put this on the number line. This is z is less than or equal to negative 1. So we'll put a bracket on negative 1 and shade all the numbers that are smaller than negative 1. So that shades to the left. Okay, that's all for this video. Please let me know if you have any questions while you're doing your homework.